Hi everyone, my name is Alexandra Pierce and I'm in Physics 2211 at Georgia Tech. This is my Lab 1 titled Constant Velocity. The purpose of this lab was to observe and analyze the motion of an object moving at the same speed without changing direction. I used a computational model in GlowScript to predict the object's motion utilizing Newton's second law, the position update formula, and the velocity update formula. I then tracked the object's actual motion from a video using tracker software. I compared this observed motion to the predicted motion from GlowScript. I attained the result that past the first few frames of motion, the object's observed motion began to deviate from the predicted motion. Using the velocity update formula, it's concluded that to have constant velocity, net force must equal zero. For net force equals zero, it must be assumed that friction and air resistance are negligible. Two key principles analyzed were Newton's first law and Newton's second law. Newton's first law concludes that an object in motion will stay in motion and an object at rest will stay at rest unless acted upon by an unbalanced force. Newton's second law states that net force is equal to change in momentum divided by change in time. This formula can be rearranged to get the velocity update formula and the position update formula. When net force is equal to zero, the object will continue to move with a constant velocity until acted upon by an outside force. The two models used in this experiment were the computational model on GlowScript and the experimental model on Tracker. First, let's look at the experimental model. For the model, I rolled a lacrosse ball weighing approximately 0.149 kilograms across a smooth, fairly level wooden table. The system is the ball and the surroundings are everything else, including the table. I recorded the object's motion and tracked the motion utilizing Tracker, which allowed me to produce a position versus time graph for the lacrosse ball. Here are the initial conditions I used in both Tracker and GlowScript. Here's the recorded video I analyzed in Tracker. Here's the graph and table of values generated from Tracker. It is clear that the velocity of the object is not constant. The slope, which captures the velocity of the ball, slightly fluctuates throughout the duration of the ball's movement. This means the ball does not move at a constant velocity because the net force acting on the ball is not equal to zero. This can be explained by the presence of air resistance, gravity, and friction acting on the ball, meaning that the net force is not exactly equal to zero. Some possible sources of air include: my ball did not move in a straight line, so there was movement in the z direction. I did not perfectly trace the ball at the center during each time frame, which would account for an inaccurate position recorded. The mass of the ball is not fully accurate, and my surface was not perfectly level, which could have impacted the speed of my ball. Now for the computational model. GlowScript was used to create a predicted position versus time model using iterative prediction. First, the initial conditions, including mass, position, and velocity, had to be set using the data obtained from Tracker. This model does not account for friction or air resistance acting on the ball, and the net force is set to equal zero. Next, utilizing the equations for the velocity and position update formulas, a while loop was created to iterate through the data to obtain the position and velocity at each time step from the data obtained from the previous step. Because the net force is equal to zero, the velocity remains constant and the average velocity is equal to the initial velocity. Here's the graph obtained from GlowScript. Time to compare. The experimental and predicted data points are nearly identical through the first 0.5 seconds, but then they begin to deviate from one another. The slope of the predicted data is constant, meaning the ball has constant velocity. There is zero net force acting on the ball. The slope of the experimental data, however, gradually decreases, meaning that the net force of the ball is not equal to zero, so the velocity is not constant. In real life, there is a net force acting on the ball, which accounts for why the experimental data has a non-constant velocity. Velocity is speed with direction, meaning it can be positive or negative according to the direction the ball is moving. Since speed is a scalar, it does not capture direction. If the ball traveled in the negative x direction instead of the positive x direction, it would change the graph. The magnitudes of the values would remain the same, but the signs of the position and velocity would change. Changing the axis would mean that the ball is traveling the negative x direction, so as time goes on, the ball's position would get more negative. Because the ball is moving in a negative x direction, the velocity of the ball will also be negative, making the slope a negative value. Here's the original graph and the new negative x graph. When an object moves with constant velocity, there is zero net force acting on it. Zero net force does not mean there are no forces acting on the object. It means the forces acting on the object cancel out, meaning their sum is zero. It is impossible to determine all the forces acting on the ball because there are many forces present in the universe. However, there are some forces that we know are acting on the ball. The force applied to push the ball is in the positive x direction, while the frictional force is in the negative x direction. The gravitational force of the object is in the negative y direction, while the normal force is in the positive y direction. After further analyzing both the tracker model and the glow script model, it was concluded that the ball did not move with zero net force, so the velocity of the ball was not actually constant. This can be explained by the presence of air resistance and friction acting on the ball.